Good morning to all the Form 5 students. Today we will discuss another subtopic, which is arc length of a circle. Okay, please open the textbook to page 5, the 1.2 arc length of a circle. So let's study the diagram. On the right shows a little girl on a swing. The swing sweeps through 1.7 radians and makes an arc of a circle. So what is the arc length made by the little girl on that swing? Okay, so let's see how to determine the arc length. Okay, arc length, radius, and the angle subtended at the center of a circle. So actually we need to know how to derive the formula for the arc length of the circle. Alright, so let's have a look of the diagram. Okay, the arc length is actually according to the diagram is actually the AB is a curve, so is subtended by the angle theta. So this is so-called arc length. Right. So as you have learned in Form 1 or Form 2 or Form 3, lower form, your teacher teach you the circumference of a circle is 2 pi r, right? And the angle subtended by a circle is 360 degrees. So let's do the comparison. Minor arc length AB, okay, minor arc length AB divided by the angle subtended, which is theta here. So we are actually making the comparison by using the ratio. So let's say the minor, I have to mention minor because the arc length we have two. One is major arc length, which is the red one. This is the major arc length, and the blue one is the minor arc length, right? So the arc length, normally we'll use a symbol SAB. SAB over theta is equal to 2 pi r over 360 degrees. So hence, if I write the arc length, it will be 2 pi r over 360 degrees times with the theta, right? Okay, now where theta is the angle in degrees subtended at the center of the circle. Okay, but what if the angle subtended is in radian? So the formula will look like this. 360 degrees is how many radian? You have learned radian for the previous lesson. So let's convert the 360 degrees into 2 pi radian. So if you cancel out the 2 pi, the formula looks very simple. Arc length AB is actually just radius times the theta, but the theta must be in radian. Okay, so if you want to use this formula to find the arc length, you must make sure the angle subtended must be in radian, right? Okay, remember? So actually I just explain to you, when the angle measured in radian, the formula that you derive will look very nice and simple. So this is the formula that you must memorize it. Okay, where S is the arc length of the circle and the R is the radius, and the theta must be in radian, is the angle subtended by the arc, okay, at the center of the circle O. From the definition, the radian, can you derive the formula as equal to r theta? Okay, you can discuss with your friend. Alright, let's have a look at the information corner. The symbol theta is read as theta, theta, okay, which is the 8th letter in the Greek alphabet and is often used to represent an angle. So theta is always used to represent the angle, right? So we have derived the arc length formula by using comparison between the circumference and the angle. Now we can solve all the question in this example. So for this one, it's quite simple. If you want to find the arc length PQ, you just take 5 times 0.9 because the angle is already in radian. So the answer for the arc length is just 4.5 centimeter, right? For this one, also the same. We just use a simple formula and then we will get the answer for the arc length PQ, which is just radius times with the angle subtended. So you will get answer which is 4 pi, right? And how about this one? Make sure the angle is the angle subtended. So you have to take 360 degree minus 140. So the angle that you get will be you may press your calculator to get the answer is 220, right? Alright, so but this is in degree, so you have to convert to radian if you want to find the arc length PQ, which is radius times with the 220. Is it like that? No, you have to convert to radian, right? So then you may press your calculator to get the answer. Okay, this is the conversion of the 220 to the radian. You got 3.84 radian, and then you just apply the formula S equal to r theta, and the answer S is 38.4 centimeter. Okay, let's recall the angle size of a reflex angle is from greater than 180 degree and less than 360 degree, right? That is so-called reflex angle. Okay, so this angle is a reflex angle. So we have acute angle less than 90, we have obtuse angle which is more than 90 and less than 180, right? And we have one more which is reflex angle, which is more than 180 but less than 360 degree. Alright, so we have complete discussing the example. So you can actually go through this example on your own. Okay, so I am going to discuss a few questions on the exercise. So before I discuss solving problem for exercise, let's revise what is the major sector. Okay, what is the major arc? Okay, major arc is here, right? and this is the major sector, the one I shaded in red color. Alright, so then this one, the one I shade in blue is the minor sector, and this one is the minor arc. Okay, so this one is the chord. This is the chord. Okay, the chord is a straight line that intersect the circumference, and then the green area here is known as segment. Okay, so make sure you understand the terms used for the circle, and make sure you go through the example, right? Okay, so I'm going to discuss a few questions for exercise 1.2. Okay, please do this exercise in your book A, and please make sure you write the index number. Okay, this one you must do in the book A. Alright, so I'm going to discuss a few questions, the rest you do on your own. Alright, so let's see number one. Find the arc length MN in centimeter for each of the following sector MON with the center O. Alright, so because the angle is in radian for this one, so for you to find the arc length MN is quite easy. So you just take 12 times 1.1, right? So the answer is, you may press your calculator and you get the answer 13.2 centimeter for this arc length. Okay, for the B, the angle still in radian, so for you to calculate this is 8 times 2, which is 16 centimeter, right? Quite easy. So let's complete the exercise. This one is arc length. You may write arc length MN is 5 times 5/6 pi. You can actually use a calculator, but make sure you use a pi given by the question. You have to follow the instruction. When you press a calculator, you cannot use the calculator's pi. You must use the pi from the given question, information from the question, right? Any problem? No. Okay, let's see. Next one, you are asking to find this part. Okay, let me highlight in blue color. Okay, so first of all, if you want to find the arc length, you must have the angle subtended. So what is the angle here? Okay, for a semicircle, the angle is pi. For a circle is 2 pi, right? For half of the circle, which is semicircle, is pi, right? So the whole thing here is pi. So the balance of this angle should be pi minus 2.45. Okay, so that is the angle, and you just times with the radius 10. You will get the answer, which is 6. Please use the pi given, 6.92 cm. Okay, right, so I have discussed question number 1, and I'm going to discuss question number 2. So question number 3, okay, you have to do on your own. Okay, so let's see question number 2. The diagram on the right shows a circle with a center O, given that major arc length EF. Where is the major arc length? Okay, let's highlight. The measure arc length is here. It's given measure arc length 25 centimeter, and then the angle is 1.284 given here. So you're asking to find the radius of the circle. So let's say the radius is r. So the angle here you actually can find using 2 pi minus 1.284, right? Okay, so if you take 2 pi minus 1.284, you get the angle for the angle that I label with a blue pen. So please remember the pi must be pi from the instruction given. So if you minus, you will get the angle for that. And then because the arc length given, so you can just take 25. S equal to r is unknown, and the theta is 2 times 3.142 minus 1.284, right? Then you solve the r, the radius, you will get the answer, which is 5, I guess. Alright, you try. Okay, so question number 3 is your homework. Okay, please do on your own. Okay, now I'm going to discuss. Okay, let me discuss. You try first and then you refer to the answer given. So the diagram on the right shows a semicircle with the radius 5 centimeter. Okay, given that arc length is 5.7, the arc length here 5.7. So the radius given, so you can find this angle, right? Let's say this angle is alpha. Okay, so we use as QR is equal to phi alpha. 5.7 equal to phi alpha. So that means the alpha is 5.7 divided by 5. Right? So your answer is 1.14 radian. Okay, so then the theta should be semicircle is pi radian, right? Minus 1.14. Okay, this is 4. So you must use the pi given, 3.142 minus 1.14. So the answer is 2.002. Alright, so the theta is 2.002. Okay, find the arc length PQ. So it's easy, right? This one, you just use S equal to R theta. Right, so R is 5 and the theta is 2.002. So the answer is 10.01 centimeter for the arc length PQ. Okay, so that's all for today's lesson for the arc length of the circle. So I will continue with the next video lesson for the determining the perimeter of the segment of a circle, which is a little bit challenging. So till then, bye bye and have a nice day.